Well, hello again, my darlings. Hope everything's going okay. I really miss you guys. I really hate doing it like this because I feel like I have stage fright. Plus, I have no idea if you're understanding what I'm doing. Although some people told me everything was great. So anyway, today we're going to talk about the side similarity theorem. And hopefully I have everything here. All right, so we've been proving triangle similar by angle, congruent to angle, but there are two other ways, and today we're going to talk about side similarity. All right, so if we're going to do the side similarity theorem, you do have to do all three sides, or actually the ratio of the corresponding three sides. So we're going to start out, as usual, with statement reason. All right, now from this example, I have to write down all the givens that were given to me in the picture. Now I'm going to stay really organized and make sure that I do the corresponding sides. So I'm going to say AB equals 3, BC equals 5, and AC equals 4. So according to what they told me, and remember the rules are they have to tell you in order, the corresponding side to AB would be, if you see I went AB, it should be DE. So DE equals 9. BC, so I have to say EF, equals 15. And AC goes with DF. All right, so that's my givens in this example. For my next step, I'm going to make the ratio of each one of these. And because I line them up with the corresponding sides and vertices, I should be able to just take it from here. So AB over DE equals 3 over 9. Now I'm going to reduce these so that they all look the same at the end. Then I'm going to say BC over EF equals 5 over 15. And that too equals 1/3. And then I have AC over DF equals 4 over 12. And once again, 1/3. Now for my reason, well, all I did right here was sub the numbers in. So this is just going to be substitution. Now I have to show you that all the ratios are the same. So I'm going to say AB over DE is congruent to BC. Well, I'll fix that little congruent sign. Remember, that's not a 2. It's just my lovely handwriting. BC over EF, which is congruent to AC over DF. And being that I strung them all together and used the congruent signs, that's going to be our ever popular transitive property. All right, now that I showed you that all three corresponding pairs of sides are congruent, I can say that triangle ABC is similar to triangle DEF, and that is by the side similarity theorem. Okay, just to review the transitive property real quick, if I tell you that A is congruent to B and B is congruent to C, you can tell me that A is congruent to C. It just makes sense. Okay, and I'm going to slide it up. Oh, by the way, I locked the dog out today. She's getting used to me being home, so she doesn't have to be under my feet constantly. All right. Okay, so now this one is a little bit different, and than the first one. So I'm definitely going to pop these triangles apart. So they're telling me triangle DBE, so I'm going to do it in that order. DBE is similar to triangle ABC. Now I'm going to put it in the same spots. The D goes with the A, the B goes with the B, and that leaves me the C right there. Okay, now, so I have 12, 14, 24. Now, just be careful right here because they don't give you that AB is 18. So I like to write it as 12 plus 6. I gave it a little circle so that I remember to say that. I'm going to have to use substitution right there. And same thing for BC. This one is going to be 24 plus 12. Again, I'm going to circle it so I remember to say it. And that's going to give me my 36. Okay. So, statement reason. Okay, so now according to the picture, I have DB equals 12, BE equals 24, and DE equals 14. I also have AD equals 6, EC equals 12, and AC equals 21. So this is what I was given. All right, next I'm going to go add these to get my corresponding sides. So I'm going to say AB equals AD plus DB, which equals 18. Because I'm going to use the same reason, I'm going to put the another step in here. BC equals BE plus EC, which equals 36. All right, now right there, all I did was, again, substitution. I subbed in the numbers and added them. So third step, now I have to set up my proportions. So I have to be pretty careful with this. So DB2, let me just put a little box here so I follow it. DB to AB equals 12 to 18, and that equals 2 over 3. Next pair is going to be BE 2. Corresponding to BE is going to be BC, and that equals 24 to 36. That 2 reduces to 2 over 3. And the last corresponding pair is DE 2, so DE to AC. I never filled it into my picture, which equals 14 over 21, which is 2 to 3. Okay, again, all I did was sub in the numbers. Substitution. Notice I reduced everything so that they all say 2/3. You actually could do it using the reciprocals. So if you get the 3 over 2, that would be appropriate. But the AB would have to be the numerator and the DB would be the denominator. So that would be just as correct, though. All right, now I'm going to use my transitive property to string them all together. So DB is to AB congruent to BE to BC congruent to DE to AC. And that's my transitive property. All right. So now that we have all 3 pairs of corresponding sides in proportion, I can use the side-side-side similarity theorem. So triangle DBE is similar to triangle ABC, and that's by the side-side-side similarity theorem. Okay, so far so good. All right, so I'm going to leave you number 3 for homework. If you could just mark it as such. I'll post the answers to the homework tomorrow, as we've been doing. All right, I just have to switch pages. Okay, so now we're on number 4. Number 4 is going to be a little bit tougher because I have these twisted triangles. So the first thing I'm going to do is highlight my triangles. Let's see. All right, it says a triangle CDA. So triangle CDA. Similar to triangle BEC. All right, I'm actually going to pop them apart because I like to stay nice and organized on this. So I'm going to call this one CDA, and the second one, so this is my blue. Now I'm doing my yellow. All right, if this one is CDA, this one has to be BEC. Okay, so now I'm going to mark my picture with what they told me so far. So EC is 4, AE is 11. Picture not drawn to scale for sure. BE is 8. So this whole thing is 8. DC is 10. All right, this whole thing is 10. AD is 5. And BC is 12. And I'm going to transfer it onto the triangles that I popped apart here. AD is 5. CD is 10. And AC, they didn't give me a number for, so I'm going to tell myself you're going to need to add these in your proof. 11 plus 4, so it will be 15. Okay, now let's see what we have on this triangle. BE is 8. EC is 4. And BC is 12. All right, so this is the only addition using substitution that I'm going to have to do. Okay. Statement reason. Number 1, I'm going to copy all this and put it right there. So la, 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 la. Given. Okay, so now, according to how I marked my picture, I need to add the 2 pieces that gave me the 15 for AC. So number 2, I'm going to say AC equals AE plus EC, which equals 15. Okay, and again, that's just substitution, and then I added them. Substitution. Okay, now I have to be organized about how I do this. Again, you could work right to left. You'll just have the reciprocal for the ratio. So for the third step, I'm going to say CD to BE equals 10 to 8, which equals 5 over 4. All right, CD DA to EC equals 5 to 4. I don't need to reduce that one. And what am I missing right now? CA to BC equals 15 to 12 equals 5 to 4. All right, again, that's just substitution. Okay, number 4. Now I'm going to string them together with my transitive property, CD to BE, congruent, DA to EC, congruent, CA to BC, and that's my transitive property. All right, now the triangles are similar. CDA, similar to triangle BEC, and that's by the side, side, side. Similarity. I'm just going to theorem like that. I spell it wrong half the time anyway. Okay, so that leaves number 5 for homework too. All right, so if you could do that. I think I'm going to make another video. I have to see how long this one is, and we'll see if I went over my time limit. Okay? Might be 2 videos.